Now let us study about the microscopic model of current. Okay, so we study current means flow of electrons we study. Okay, but exactly how does the current flow in a wire? Okay, that we're going to study now. So let's take a wire here. I'll draw a wire like a big cylinder. Okay, like this. Then we imagine that electrons travel from this part to this part. Okay, inside the conductor. So this is like a conductor here, wire. So I'll take a region here like this way. So electrons travel from this part to this part here. Okay, so it will be like a circle only. Okay, see if you take a chalk here. Okay, I have a chalk here. This part of the chalk, okay, it's like a circle. Okay, but this side is like a cylinder. So wire is also like a cylinder, but look from this side, it's like a circle. So this will have area A. Okay, and then let's take the distance here from here to here. The distance is dx. Okay, the distance it travels is dx here. So electrons travel, say, from left to right. Okay, this is the electron, it travels from left to right. Okay, so electron here travels from left to right. Let's see. Now we see this distance here, we can also say it as velocity, the drift velocity, okay, Vd into dt. Okay, we'll see how it comes later. Okay, now you know the drift velocity, okay, means the velocity with which the electrons travel inside the conductor. Okay, so drift velocity we say it is Vd. Okay, drift velocity, that is Vd. Then next we see velocity means what? Distance by time, or displacement by time. Okay, so velocity, drift velocity Vd is equal to the small distance dx, okay, by the small time dt. Okay, so you cross multiply upwards here. So what we get is Vd into dt is equal to dx. Okay, that we can rearrange, and what we will get? We'll get here dx is equal to Vd into dt. Okay, just rearrange here. So this means drift velocity. This is a time, small time here. Okay, now what we do is we see, we'll draw a line here first. Okay, how many electrons are in the volume of the conductor? So this is a wire here. Okay, how many electrons are passing in the full volume, that you can see. Okay, so let's take the total electrons available in the entire volume. Okay, in the volume of the conductor, the entire volume, that is equal to, we see, we must take the volume, full volume. Okay, so first I'll take the volume here, volume into the number of the electrons here. Okay, number of electrons per unit volume. Okay, number of electrons per unit volume, electrons per unit volume. Okay, let's study how to get this now. So we know volume means it is area into distance. Okay, area into distance will give us volume. Okay, into the number of electrons, that I read as n. Okay, unit volume means what? We'll take 1 meter cube. In 1 meter cube, how many electrons will be there? That is called as number of electrons per unit volume. Okay, now we got this now. Now what we do is we see dx is there now. Okay, this term dx is there. Okay, let's substitute the value for dx. Substitute value for dx now. Okay, substitute value for dx, what we get is this term. Instead of this, you write here. So we get here a into vd into dt into n. Okay, this quantity we get here. Okay, after substituting. Now what we see is we will see the total charge flowing. Okay, total charge will be the number of electrons. Okay, electronic charge. So let's take the total charge here. Okay, total charge, that is dq here, is equal to electron charge. Okay, this is a total number. Okay, this is just a number only. Okay, just a number. Now you must get charge. We know charge formula, q is equal to, we have to form now, q is equal to ne. Okay, so now we got n. So multiply by e here. I'll write e front. Okay, so e into a into vd into dt into n. Okay, now we got this thing now. But let's see what's meant by current. Okay, current I is equal to the flow of charges per unit time. Okay, that is like as dq by dt. Okay, let's see this now. I'll erase this formula here. So this dq term you divide by dt. So E into A into, or before I can write the n front here. Okay, n I'll write front. A into Vd, okay, into dt divided by this one dt. So dt is a dt and dt will cancel. Okay, so what we get for I, you see the formula for I comes to be n, okay, E, I write Vd here first, then A. So I is equal to n E Vda. Okay, so it's very simple to understand. Okay, how to get the, remember the formula. A simple trick is that, see in the US there is a hill called as, or a mountain called as Nevada. Okay, Nevada mountains are there. So NEVDA. So you can remember this thing. Okay, mountain for the current here. Okay, so here I means the current, N means number of electrons, E is the charge of one electron, Vd means drift velocity, A is the area. Okay, so in this way we can see the microscopic model of the current. Okay, just go through the equations carefully. It's very simple only. Okay, go step by step.